Welcome to the Walton Pie. Today we are going to be talking about equivalence relations. If you're not sure what a relation is or would like a review, please see my last video about relations and functions. So to begin, we need to establish three different types of relations before we can start to talk about equivalence relations. The first of these are reflexive relations. So a relation from A cross A is reflexive if for every single little a in the set A, the pair A comma A is in the relation R. So, if the set A is the set containing A, B, C, D, and E, would this be a reflexive relation? Look to see if for every element in A, the pair, for example, A comma A or B comma B, if that is in the relation. Hopefully you've had enough time to be able to look through and see, and by looking and finding the pair A comma A, B comma B, C comma C, D comma D, and E comma E, we see that this is reflexive. Now let's look at this other relation. Is this relation reflexive? Hopefully you were able to spot that the pair B comma B is not in this set. So this is not reflexive. Even though there are other pairs like A comma A and C comma C, because we don't have every possible pair of A comma A or B comma B, this is not reflexive. We need every single possible pair of A comma A or element comma element to be in the set in order for it to be reflexive. The next type of relation are symmetric relations. So a relation is symmetric if any time we have the pair A comma B, then we also have the pair B comma A. So, looking at this example, see if you can figure out if this is symmetric or not. I'll give you a moment to figure it out. Hopefully you were able to spot that this is not going to be symmetric. Because if we go through and look at the different pairs, so we have A comma B, so we should also have the pair B comma A, which we do. But then when we look at the pair A comma C, that tells us we should also have the pair C comma A, which is not in the set. So this is not going to be symmetric. All it took was for that one pair, C comma A, to not be in the set for it to not be symmetric. Let's look at this example and see if you can figure out if this is symmetric or not. Again, I'll give you a moment to try and figure it out. Hopefully that was enough time for you to figure it out. It turns out that this one is symmetric because anytime we have a pair, like A comma B, we also get the pair B comma A, and that's true no matter which pair we pick. So if we see that there's the pair E comma B, we should also then be able to find the pair B comma E. A third type of relation is what's called a transitive relation. So a relation is transitive if any time we have the pairs A comma B and B comma C, and both of them are in R, then the pair A comma C must also be in the relation R. So, here is an example. Let's try and figure out if this is going to be transitive or not. So, if we look and we see that we have the pair A comma B and B comma A, from our rule, that tells us that because the B's match on the insides, we should also have the pair A comma A, which we do. So that is one set of pairs that worked out. We can also see that we have the pair C comma D and the pair D comma E, so we should also have the pair C comma E, which we do. Now, by just checking those, we might think this is transitive, but it turns out this is not, because we have the pair B comma A and the pair A comma B. Putting those two together in that order tells us that we should also have the pair B comma B, which is not in the relation. So this is not going to be transitive. It's important to check every possible pairing to see if it is transitive, because like this one, it might pass every other possible pairing, but just that one set of two pairs that make it break, this is not going to be transitive. Now, let's look at this example. See if you can figure out if this is going to be a transitive relation. I'll give you a few moments. Feel free to pause it if you need more time. Hopefully that was enough time for you to be able to figure out if it's transitive or not. It turns out that this one is transitive. There are quite a few pairs that we have to check, but it is going to be transitive. Now that we've defined symmetric, reflexive, and transitive relations, we can define what an equivalence relation is. A relation is an equivalence relation if it is reflexive, symmetric, and transitive all at the same time. If it's only some of them but not all of them, it is not going to be an equivalence relation. It needs to be all three. So, an example of a relation that we might try and see if this is an equivalence relation might be this one. We have A, B, C, C, D, and so on. Take a minute to check to see if it is reflexive, symmetric, and transitive. Hopefully you were able to spot that this one is not going to be an equivalence relation. It is transitive, but it is not reflexive or symmetric. We do not have the pair B, A, and we also don't have the pair B, B, and those are the pairs that break that. Let's look at this example. Try and take a minute to figure out if this is reflexive, symmetric, and transitive, because if it is, then this is an example of an equivalence relation. Hopefully that was enough time for you to be able to figure out that this is going to be an equivalence relation. It satisfies all the necessary requirements to be reflexive, symmetric, and transitive. I hope you enjoyed this video, and I hope that it was helpful for you to be able to see different kinds of relations. If it was helpful, please like and subscribe, and feel free to check out some of my other videos. Have a great day.